Diffraction is the spreading out of a wavefront from a straight line into a curve. A wavefront is a line of particles all moving upwards and downwards, following the pattern of a wave. The particles are all moving up in step with each other across a distance and all demonstrate a peak at the same time. They are caused by a line of particles being driven upwards and downwards at some distance behind the wavefront in the medium. When a wavefront reaches the barrier, the energy contained within the particles can no longer be passed forward onto the next line of particles in front of the wavefront. The particles that would normally be pulled upwards by the ascending row of particles are now fixed, and so, instead, this force is directed backwards towards the row of particles behind. The wavefront reflects off the barrier because the particles of the barrier will not move as easily as the particles in the medium. When a wavefront comes across a gap in the barrier, the situation becomes more complicated. Some of the particles in front can be raised upwards and pulled downwards with the particles behind them, but not all of them. Many of the particles in the gap are rubbing against the barrier and do not receive the same amount of force from the particles behind. The particles towards the edge of the gap are not receiving the same amount of force as the other particles further away from the edge of the gap, because these particles have fewer neighbours to pull them upwards and downwards. This means that the rise and fall of the particles in the gap is different to the rise and fall of the particles before the gap. All these interactions between particles have the effect to slow down the wavefront at the edges of the gap, whilst the wavefront in the middle of the gap continues to travel at the same speed. This leads to a wavefront changing shape and spreading out into a curve rather than a line, close to the edges of the gap. As the size of the gap becomes closer to the wavelength, the dispersion of the wave becomes more and more circular. When the gap in the barrier equals the wavefront is circular. The wavelength represents a maximum distance over which any particle has enough energy or force to have an effect on another particle. If a particle is within one wave, then the interaction of forces within that wave combine to keep the wave shape. A particle being forced to rise forces a particle in front of it to rise, and so on. The speed at which the particles are moved determines the frequency of the change in waves from peaks to troughs. In effect, once a particle has gone through an entire cycle of moving up and down, it no longer has an effect on the particle in subsequent cycles, or subsequent individual wavelets. So when a gap is the same size or smaller than the wavelength, the particles that make up the wavefront have not had time to complete their cycle and make the next particle move before the next wave is making them move. The gap is having the effect of slowing down the entire wavefront and not just its edges, and so all parts of the wavefront are slowed down, and the amount they are slowed down is determined by their proximity to the gap. If we reduce the gap even further, we slow down our wave even more and make shallower and shallower waves.